Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Sabi Ibrahim. Today our group will present about spelling checker problem. This is our group members. First, Alif Iman. Second, myself, Hamzah Ibrahim. Third, Shafi Ashraf. And fourth, Ahmad Hazib.
Assalamualaikum warahmatullahi wabarakatuh. My name is Raf, and now I'm going to briefly explain about the history of spell checking. So actually, spell checking began in the late of 1960s, where many researchers at that time used a list of words that were spelled correctly, which is also known as a dictionary, which is a term that we use nowadays, and compare them with an input of string or a word. But after sometimes they found out that this method, which is using the dictionary, is not effective because they need to compare the word with a word in the dictionary, which comprises many words or phrases, and call it as inefficient. So Morris and Cherry developed an algorithm that uses the frequency of character trigrams to calculate an index of peculiarity. So actually, index of peculiarity is a coefficient that will be used to calculate the probability of occurrences of a given trigram in English. So we can say that if an input is a word of what, and the frequent trigram exists in English is WHA, which is wa, meaning that uh, the input spelled correctly, whereas if the input is WAHT and the trigram is WAH, which is rarely appear in English, therefore this algorithm will assume that the containing trigram as a misspell. Later, Malcolm Douglas McIlroy, an American mathematician, engineer, and programmer, suggests a minimization technique called affix stripping to overcome the issue. And this idea is use a method to store the stem of word of a string. So let's say we have some words like reading, readable, and reads, which are derived from read. Um, it will store the stem word, which is read. So the method can be said as effective in identifying a misspelled word, but actually it failed to suggest suitable target words. As in this process, non-existent words were often generated, such as unreading or relation. Sometimes human can make like typos or spell this word. Another technique has been developed later in the year of 1980s and 90s, where it uses confusion sets. So confusion sets actually is a word is I would say like it's a small set of words containing uh, 3 to 4 words that are likely to be confused with one another. For example, like there, they are, and they are, which is sounds like similar, but actually they are different. And similarly to principle and principle, PLE with PAL. And another string matching algorithm is based on the notion of edit distance by Vladimir Losifovich Levenstein, or can call it as Levenstein algorithm. He is a Russian and Soviet scientist, which then this algorithm is extended to Wagner-Fischke algorithm, which is developed by Robert A. Wagner and Michael J. Fischke. So actually, if the misspelled word was yacht and the candidate was yolk, we can get the yolk to yacht by changing several letters in it. For example, we change the K into T and omitting the letter E, in which resulting two changes. So actually, Levenstein here wants to calculate the edit distance. So in this case, when we want to change U to yacht, the edit distance is 2. So Levenstein suggests that the lower the edit distance means that the closer it matches to the correct spelling word.
How does the system can be implemented? Implementing a spell checker involves scanning the text and extracting the words contained in it. An LP is the most used technique to implement the spelling checker software tools. First step is creating a software, which are processing the text data, creating a dictionary, comparing a word, generating the suggestion word, and presenting the suggestion. There are two separate styles of spelling checker tools, each showing different methods for identifying and correcting spelling errors in written text. The standard spelling checker works on a regulated, rule-based algorithm and a finite state automata. This system works by comparing words against a predefined dictionary and following a set of rigid rules to flag out possible misspelling. And the current one, which we are currently using, are statistical language model and machine learning. Rather than depending on the fixed rule, the spelling checkers will analyze a variety of collection of written text to identify the pattern and the connection between each word.
Assalamualaikum, my name is Amar Hazik and I will be explaining how the spelling checkers work, and for today's example I'll be using the word anti-disestablishmentarianism. So this is the automaton for the checking of the spelling anti-disestablishmentarianism and its other syntaxes such as a capital letter A and also all capital letters. As you can see, it starts with two options of a small a or a big A. Then it moves on to the rest of the letters until to the final state, which is state 28. So this is how it works, and let's see it in action. So how does this thing actually works? So this is an automaton tester, so we can test if our automaton actually works. So let's test this with the word anti-disestablishmentarianism. And it works. Now, what if all capital anti-disestablishmentarianism? It works. Now, what about just a capital A? Yep. All right. Now, what if you spell it wrong? Maybe anti-disestablishment, but with a DE instead of a DI, and it failed. Now, why? It got rejected because here, in here, you see it went from A, N, T, I, D, and it's supposed to go with I to go to the next state, but instead we use an E, and there's no E, so it falls into a reject state. And that's how spelling checker with automata theory works. So thank you for watching.